Finally, let's cover regularization, which also combats overfitting by applying a penalty. How do L1 and L2 regularization differ in their mechanism and their effect on the resulting model? Regularization is a modification to the loss function. We calculate the standard error, and then we add a penalty term based on the size of the weights. The fundamental axiom is that large weights typically correlate with overly complex models that are too tailored to the training data. So you are financially, or I guess mathematically, penalizing the weights for being too high. Exactly. Now for the crucial difference between L1 and L2. L2 regularization, that's R2 equals lambda times the sum of Wi squared. This penalty is based on the sum of the squares of the weights. Squaring them really emphasizes the big ones. It strongly penalizes large weights, forcing them to become smaller and more evenly distributed. It creates a stable, well-generalized model, but it rarely forces any weight exactly to zero. And L1. L1 regularization R1 equals lambda times the sum of the absolute value of Wi, this penalty, is based on the sum of the absolute values of the weights. L1 has a unique property. It encourages sparsity. It drives many less important weights precisely to zero. Why would we want weights exactly at zero? Because L1 acts as a built-in feature selector. If a feature input or the output of a hidden node isn't truly critical, L1 regularization will eliminate its corresponding weight entirely. It effectively simplifies the model architecture and makes it easier to interpret which inputs are truly driving the prediction. I see. So if you need interpretability or you know that only a subset of your features matter, L1 is preferred. That's right. And if you prioritize maximum generalization and stability, L2 is often the better choice. In both cases, the parameter lambda determines how fiercely we impose that complexity penalty. We've built the engine, tuned the throttle, and engineered the safeguards. We have a stable, powerful, mathematical machine. Now let's apply this optimized system to the great unstructured chaos of human communication. The transition from the mathematics of optimization to the fuzziness of language can be jarring. It is, but it's the logical next step.